All right, this video I'm going to go over the trickier problems on the midterm, the second midterm. So if you choose to retake it, hopefully you can understand what I did here, maybe better than what's on my answer key, which I'll post those too, but sometimes it's easier to see it in progress. Okay, so number one is definitely one of the trickier ones that more people had trouble with. So we want a linear to linear model, which means it's going to look like this. And A is the x asymptote. In other words, it's times, because I have a t here, not an x, so the t asymptote. As time gets really, really big, then these numbers don't matter anymore. The t's canceled in and we get A. In this case, I said that as time goes on, it reaches 40 degrees. So right away we know A is 40. So we can rewrite this with the A being 40. So 40t plus B divided by time minus C. Now you use the data points I give. I said at time 0, they start off at 75 degrees. So 75 is equal to time 0, that's 0. So we just have B over negative C, because t is 0, t is 0. Or B is equal to negative 75C. So if we know C, we can find B. So we use the other data point to find C. I said in 3 hours, they had a temperature of 60 degrees. So do this again. So 60 in 3 hours. 3 times 3. 3 times 40 is 120. 120 plus B. B is negative 75C, so I can just put negative 75C in there, right? Because B, we already figured out is negative 75C. T is 0. Wait. T is 3, so we have 3 minus C in the bottom. So all we have is a C. So we can figure out C, and then we can find B once we get that, and then we know what our function is. And we're done. So I can cross multiply. 180 minus 60C, 3 times 60 is 180, yep, equals 120 minus 75C. I'm going to put the 75 over here. It'll beat the 60 by 15, right? Positive 75 minus that. So that gives me 15 C's. 180, 120 minus 180 gives us negative 60. Or C is negative 60 divided by 15, which is negative 4. Okay, now we know our function. Now we can write it. Y is equal to 40t plus B. Oh wait, I didn't do B. C is negative 4, so B is negative 75 times negative 4, which is 300. Okay, so 40t plus 300 divided by t minus C. T is negative 4, so t minus negative 4 is t plus 4. And that is our answer. Now, whenever you get an answer, you should check it. Real easy to check. Plug in time 0. At time 0, we know it was 75 degrees. Do we get 75? 0, 0, what's 300 divided by 4? 75. We could also plug in time 3. Do we get 60 degrees? So plug in 3. 120, plus 300 is 420 divided by 7. That's like 42 divided by 7 is 6, so 420 divided by 7 is 60, so we get 60. So we know it has to be right. If we can get those right, it's just got to be right. So always check your answers. It's real easy to make a mistake, like the negative 4, made it not minus or something. Super easy. A lot of people did, just made silly mistakes. Check your answers. Okay, that was number 1. Number 2, I think you can figure out if you got that one wrong from the answer keys. It's just solving for x, pretty much. So I'll skip that one. So let's go to number 3. Number 3 was the population one, I think. Yep, the population one. Right away, we can write down the population for A, because I say it starts off in 2015, which is the earliest time given. The earliest time given you call time 0. So we'll call it 2015 times 0. So it starts off at time 0 with 3,000 people. So A, population A is 3,000, the beginning time, times B to the T. And I tell you what B is because I said at the end of the year it had 20% more people. That means it's not a continuous growth rate. If it's growing continuously at 20%, at the end of the year you might have 23% more people or 24% more people. So we use the B to the T formula, where B then is 1.2. It's B is 1 plus the growth rate if it's like this at the end of the year. So I know B is 1.2. So right away I'll just write that B is 1.2. Again, the 0.2 is a 20%, right? 20% is 0.2. If it's 2%, it'd be 1.02 to the t. Now, the tricky part is to figure out for b. Okay, so b, we write the general formula. It's the time at time 0 in 2015, right? So t equals 0 is 2015, times a new b to the t. The b tells us how fast it grows. B0 tells us how many there were when we started. Okay, so we got to figure that out. So I give you 2 points. We have 2 things we don't know. We got to have 2 data points. Let's see, I said doubles every 10 years, had 7,000 people in 2019. Let's do the double of every 10 years. In 10 years, when this starts off at B0, 10 years later, that's 2 times B0. So 2B0 equals B0 times B to the T. Oh, and it's doubles every 10 years, so 10 years later, so time is 10. Okay, the B0s cancel. We have 2 is equal to B to the 10th. To get rid of that, we want what B is. We do it to the 1/10th power, because exponents multiply. 1/10 times 10 is 1. 2 to the 1/10th power, you plug in your calculator, 2 to the 1/10th power, or 2 to the 0.1, which is tricky. Make sure you can do that. And I think I did that, and I got 1.071. I kept lots of decimal places. So B then is 1.07177, which means it's about a 7% growth rate, right? So 0.07, about a 7%. This town grows much faster. A is growing at 20%. The B is only growing at 7%. So B grows slower. And now we can figure out what B0 is. So we know that B is equal to B0 times 1.07177 to the T. And then I tell you one more point. Oh, I see they double. I said that in 2019, there are 7,000. 2019 is T equals 4. So there are 7,000 equals B0 1.07177 to the 4. Again, T equals 4 because it's 2019 and T equals 0 is 2015. Okay, so now we can figure out B0. We got to raise this to the 4th, put it over here. So we get that B0 is 7,000 divided by all that, whatever that is. So you put that on your calculator, which again is tricky. Make sure you can do that to the 4th. And I got that it was about 5,305. So there are 5,305 people at time 0. After 4 years, there are 7,000. And it grows at a 7% growth rate. Now we can write what B is. B is 5,305 times 0. That's how many there were. They grow at this rate, it's a little over 7% to the T. All right, now the question is, when does town A have 3 times as many people as town B? We know A is growing faster, right? Grows at 20%, B is only growing 7%. So the last step is we say A is equal to 3 times what B is, 3 times what B is. A is 3,000, 1.2 to the T equals 3 times B, 3 times 5,305, 3 times 5,305, 1.017177 to the T. We need to know T. So we put this over here, or the 3,000 on the other side. I think I did it that way. This is a bigger number. I like to have bigger numbers on the top. So we have 1.2 to the T divided by that. I'm getting tired of writing this number. 77 to the T equals, this is what, 15,915. 15,915 divided by 3,000. Okay, the way you solve this is you put them as one thing. Something to the T divided by something to the T is like the whole thing to the T. 1.2 divided by 1.0177 to the T equals whatever that was. I didn't even write that down. And then you take the ln of both sides. ln of all this equals ln of 15,915 divided by 3,000. When you do this, ln of something to power, the T goes in front. So I can, let me just save some room here, I could put this t in front and take it off of here. Something, right? The rule is ln of a to the b is equal to b ln of a. That means I can solve for t. That's the trick to solve for t. Okay? Most of you got this, but I'm just going over that. So t then is the ln of that, ln of this thing here, divided by the ln of all this, divided by the ln of all that. And if you do all that and check this in your calculator, make sure you can do it right. I got like 14.77 and then it's years, so we might as well write years. So in 14.77 years, and that is from time 0. So if we want to know the date, and I took 14.77 years, but if we want to know the date, we add that to 2015. Okay, so if I ask for the year, it's about 2030 or something, a little less than 2030. But it's always from time 0. Okay, good. Hope you could follow that. Made sense. Last one we'll do. Number 5, I think most people, I think you could follow if you messed up, which was wrong. And number 6, people did really well on solving for the logarithms. Again, I think you could follow that. Number 4 created the most problems, which I was figuring it might is a tricky problem. So we need to go over number 4, the wheels. So let's go over this wheel problem. Ooh, that means I have to draw a picture of it, I think, or I could turn the projector on. But that would take a while. So I'll just draw the picture of it. Won't be too bad. Okay. So, the wheels. Okay, draw a picture of it. So you can fast forward while I draw the picture. So we have wheel A, and then we have the wheels in the middle with the little one, and then we have another big one, the biggest one. Try to do it to scale. And then we connect these to here, and the little one to here. And we said this one, which is A, had a radius of 8. And this one, which is B, the big one is B, has a radius of 5. So here to there is 5. And the inside one had a radius of 2. That's wheel C. And wheel D has a radius of 10. And this one spins at 4 RPMs. I think that's all we know. And we want to know what wheel D does in radians per second. What's omega of D? And I said radians per second to keep it interesting. So we're given RPMs, we got to change to radians per second. All right, so basically what you do is you start here and you work your way over to here. And there's really only one formula we're going to use the entire time, and that is that the velocity is omega r, or we can solve for omega. The omega is equal to the velocity divided by r. We're just going to use that same formula, which is right same formula, but I can do the algebra 2 different ways. Okay, so let's start with units. Let's change the RPMs to radians per second. So we know all our units are right, and then we can just keep going. So we got to change 4 RPMs to radians per second. So let's see, where should I do that down here? 4 revolutions per minute. That's what an RPM is, right? 4 circles per minute. We want radians per second. So let's see, one revolution is 2 pi radians. 1 circle is 2 pi radians. That cancels out the revolution, and then we want seconds. So 1 minute is 60 seconds. Let's see, minutes cancel, revolutions cancel, radians per second. So that's right. So you do that, 4 times 2 pi divided by 60. It's going to be a small number. I got that as 0.419. So 0.419 radians per second. That's how fast this is turning. Now we can figure out the velocity of the cable here. Let's call this V of A, which is equal to V of B, right? These outside of wheel A has to be moving the same speed as the outside of wheel B because they're attached by a belt. Their belts goes the same speed. So what's the speed of the belt? VA is equal to VB. We can figure out what VA is because we know omega A and we know the radius of A. So VA is equal to omega A times the radius of A. Omega A we just figured out was 0.419. And I know I have the right units now, okay, so, and we're going to have inches. Everything is in inches. We're in radians per second, so I don't need to worry about units anymore. So I'm just going to write the numbers. So omega A is 0.419, 0.419 times the radius of A, which is 8. Okay, you do that math, and I got 3.352. 3.352. That's VA. Now I can figure out omega B, how fast B is spinning, because omega B is equal to V of B divided by the radius of B. And V of B is equal to V of A, and V of A, because they're connected, right, as we just said. And V of A is this, that's what V of B is, so 3.352 divided by B is 5. So you do that, and I got omega B was 0.67. So 0.67 radians per second, which I know because it's omega, because we have those units. Okay, 0.67, which means C is 0.67. That's equal to omega C, because they're connected. If this is going 0.67, if B is going 0.67 radians per second, so is C, right? They spin together. So now I know omega C is that. Now I can figure out D here. I can figure out the velocity of D, because the velocity of D is equal to, oh, wait. I need to figure out this, this velocity here. Okay, call that VD, because VD is the same thing as VC, because they're connected by a belt. The velocity of this outside wheel is turning is the same as this velocity is turning. Okay, and VC is omega C divided by the radius of C. We figured out omega C is the same as omega B, because they're connected. All this. Some people made a chart, like a box. That can be really helpful. I don't do it that way, but some people recommend doing it that way. If that helps you, great. Just make a chart, writing all these things down. I just like looking at the picture and working my way over. That makes more sense to me, but whatever works for you. Omega C, we said, is 0.67. The radius of C is 2. That's a really bad 7. 0.67 divided by 2. Should be able to do that in my head, but I don't feel like it. VC is omega. Okay, good. Maybe something was wrong. Okay, always look at your formulas. See how easy it is to make a mistake? Velocity is omega r. You start doing this a lot, you start doing the wrong things. Velocity is omega r. So omega c VC. You multiply them. So 0.67 times 2 is 1.34. Right? It's 1.2, 1.24. Yeah, that's right. Yep, this I got before. Okay, now that's what VD is. We can figure out what omega D is. So omega D, make sure I use the right formula. So I wrote them down over here, then I violated my own rule. But I caught it, is equal to V over R. So VD divided by the radius of D. We just figured out VD here is 1.34. The radius of D I said was 10. So finally, we get the answer. Divide that by 10, just move the decimal place over, 0.134. And we know we're in radians per second because we changed it a long time ago. So it's that many radians per second. And we're done with the hard part. That was the hard one. Okay, working all the way across. Okay, you gotta be really systematic. Just call it. It really helps to call things what they are, to set them equal. VA is equal to VB, omega V is equal to omega C, all that kind of stuff. It really, really helps that. Or make a chart and change the units right away. And then once you know your units right, everything is inches, everything is radians per second. You know you're going to get either inches if you're looking for radius, or radians per second if you're looking for omega. Okay, the last one then. What's the outside of wheel A in miles per hour? This is just really checking how if you can convert. So let me do that down here. So you didn't even have to do part A. I made us even have to do part A to do it, because I told you, because velocity, what's the velocity of wheel A in miles per hour? So the velocity of wheel A is omega A times the radius of A. We already figured out omega A was 0.419 radians per second, or we could use 4 revolutions per minute. Let's use the radians per second. So that's 0.419. Actually, I'm going to have to do it down here because I'm going to do a whole lot of stuff here. Let's do it up here. 0.419 radians per second times the radius of A was 8. So times 8 So that is, actually I already figured this out, huh? VA right here, 3.352, I already did this. 3.352. What are those units? That's inches, because it's 8 inches, inches per second. Inches per second. Radians kind of don't count. They just kind of go away. That's the magic of radians. So the units I had here were times 8 inches, the radius is 8 inches, and omega is per second. So 3.352 inches per second. So 3.352 inches per second. Okay, that's not very fast, right? You're going like this much a second. That's going to be a really small miles per hour. So just be aware, we better get a small miles per hour. Okay, now we just do all our unit things. Let's see, so we need a second. So how many seconds are an hour? 3,600 seconds is 1 hour. That cancels out the seconds. We need to change inches to miles. I know that there are 12 inches and 1 foot. And I put the inches in the bottom so it cancels. Yep, that's right. And I know that there's 5,200, oops, I need to put that on the bottom. 5,280 feet is 1 mile. The feet cancel, yep, I did it right. And you do all that, and I got like 0.19 miles per hour. You're left with hours in the bottom, miles at the top. Do all that math, and I got like 0.19. So make sure you can get that on your calculator. So, okay, on the retake, I'm just gonna change numbers around. I'm gonna change this problem a little bit. I'll ask for omega C or something different, but same numbers. Give you everything you need to know except for the one thing. But you do it the same way. I'll change them around a little bit, but you kind of do everything the same way. Be very systematic about it. Use these 2 formulas. Work your way across. Be really careful with the math. And yes, so anyway, if you got these wrong, hopefully it makes sense to you. There could be ones like this in the final, like, right, I don't make the final, so who knows what's going to be on it, so really make sure you got this down. All right, good.